share my screen. Cool. Welcome, friends. This is another fun session, a combination of happy hour plus one notebook that we're gonna explore together. This is Deep Learning Adventures. You can find us on Meetup, on YouTube, on Kaggle, even on social media every now and then when we post events. I'm George. I'm joined by great friends and colleagues all around the world, and as well as my great friends and co-organizers, Robert and David. Welcome, everyone, especially new members. Today, we're going to talk a little bit about a new notebook that the Kaggle team released as part of their geospatial analysis class. And I think it will spur a lot of discussion for us to see what kind of interesting data sets it's using and how is it using it. If you're joining us for the first time, there was a recent update on our schedule. We're supposed to do another event today. We're going to do it maybe in a couple of weeks. But if you're joining us online, after the notebook next week, we're going to do an overview of the TensorFlow Everywhere, which is like TensorFlow Summit that was held end of February. And then we're going to do the event that we're supposed to do today on Highlight, looking at some advanced notebooks as well as hungry keys, which Alexander is going to cover for us with Dimitri. And then Robert's going to take us on another trip using his project that he built for the bike share project. As usual, this session is recorded and is available on our Kaggle courses YouTube playlist. The last session we did was the Highlight navigation, where David and I compared our agents and had fun exploring different strategies. I'll post the links for you to join here on Slack as well as YouTube. And I'll start with the introduction of this bonus lesson on the geospatial analysis course. So we covered this, I don't know, a couple of months ago. It was a very interesting course for me. I use it as well as on my day job as well. Geospatial analysis is something that I think is a useful tool for everybody. It introduced us to this new toolkit and library called Folium, and really allowed us to build dynamic maps pretty easily and in different forms. Could it be horopleth, or could it be circles, or could it be just a simple map? It was very easy for us in a dynamic way to create maps. So this notebook covers two interesting data sets, and one of them is what is the population at each state in the US, as well as the latitude and longitude of each capital city. And the author here has this source for us. So as you can see, this is the first data set. There's a state field. There's a population estimate from US Census 2019, and a latitude and longitude from the state capital of each state. And then the second data set is what is called the vaccine data set. And this is drawn from this interesting new platform. I don't know if you've heard of it. I've only come across it through this notebook called Our World in Data, which updates their data sets, I think, quite regularly, and maybe on a daily basis. So this is our second data set, and I'll cover each and every field. What does that mean? But as you can see, so the last commit was 5 hours ago. I think this is done through a bot, probably, or updating it from maybe CDC website. There's a date, a location for the state, and a lot of fields like total vaccinations, how many people are vaccinated, how many people are fully vaccinated, and some percentages in terms of hundreds or millions of population. Let me cover the fields real quick because it's important for us to understand the data before we analyze it. So for this CSV file, the location is the state, the date is the date at the day level. Total vaccination is number of total doses administered, and this counts every single dose that is administered to different people, even if that person is the same person. So if somebody gets 2 doses, this number will go up by 2, even if it's the same person. Total vaccinations per 100 is this number above divided by per 100 people in total population of the state, like a percentage. Daily vaccinations, I think this is a daily change. We're not going to use this field. So what was the difference from day to day? That was daily vaccinations raw. Daily vaccinations is 7 days smooth average of how many doses were administered. We're not going to use this either, like per million. This is something that we're going to use. People vaccinated. So this is the total number of people who received at least one vaccine dose. As you might know, different countries have different regimes, and most of them usually have a 2-dose protocol. So it says here that if a person receives the first dose of a 2-dose vaccine, this metric goes by 1. If they receive the second dose, this metric stays the same. Then the same number divided by over 100 people in the total population. And fully vaccinated is a metric that I think is more representative of the actual vaccine impact. So this is a total number of people who receive all doses prescribed by the vaccination protocol. So if there's a 2-dose protocol and a person receives only 1 dose, this metric won't change. But if the person receives a second dose, then this metric goes up by 1. Total vaccinated per 100 again, then total distributed. This is something as recorded and shipped by CDC's vaccine tracking system. Per 100 used, how many of them were administered among those recorded? I'm not sure we're going to use this, probably not. And this is a simple example here. Dina, so let's say we have a scenario where 2 doses are needed to be effective against the disease. Tina has received 2, Joel received 1, Tommy 1, Ellie none. How many were administered? 2 plus 1 plus 1, 4. How many were vaccinated? That would be 3. 2 plus Dina, Joel, and Tommy. How many were fully vaccinated? That would only be 1 because Dina only is the one that received 2 doses, assuming this regime, which we have in the US. Cool. This Our World in Data, ourworldindata.org. It's a very fascinating and interesting resource. I'm going to cover all these other resources of the notebook after we go over it. So I'm going to pause here and go back to our notebook. Any questions about the 2 different data sets we're using? Feel free to chat or unmute yourself. So basically we have a census data, how many people have for each state, and how many vaccines people have received in each state. Okay, so let's do some basic analysis. We're using pandas, some date times, some date and date time delta to do some different calculations. Volume is the package that we use extensively for geospatial analysis. Marker is one library that allows us to create markers of different colors or different shapes. The cluster is what allows us to, when you are zoomed out, to cluster the different markers into one cluster instead of looking at it, all the markers together. Math, we're just doing some math operations in terms of rounding things at 2 decimal points, plotting for visualizations. Okay, why it keeps asking. And Seaborn for visualizations. The first data set is this census by US population that we're going to look at. So again, this is this data set with just 4 fields. In terms of date, we're going to look at yesterday's date. Probably today's date is still under update and refresh for both data sets, for the vaccine data set. So we're going to use today's date and we're going to go back in time 1. That's why we look at here is March 23rd. And then the second data set is this Our World in Data US State Vaccinations.csv. This one here, which is at the state level. We're only interested in location, which is a state. People vaccinated. The notebook only had these 2 fields. I added this 3rd field as well, which is people fully vaccinated. We will join the population data, which is the census, the census data with this vaccination data frame. left on state, which is the state, and right is the name of the field which contains the state information on this vaccine data set. Then we're going to drop it so we only have one state field. We're going to do a simple calculation how many people were vaccinated over total estimation, total people inhabiting that state or living in that state as of 2019, as well as fully vaccinated over the entire population. So let's select, this is the date for yesterday, and let's take a look at the different fields. So for the second data set, date, location, total vaccination, people vaccinated is one that we're going to use, and fully vaccinated. Let's look at it in this data frame overview. It might be easier to read. So this is the joint data set of population and vaccines. So let's say, for example, Alabama, almost close to 1 million were vaccinated, 600K, almost 500K, fully vaccinated. The percentage of people vaccinated over the population is 20%, and only 11% have been fully vaccinated. And we can say this for different states. If we want to aggregate this at the country level, we sum up how many people were vaccinated, we sum up how many people are living in that state, we divide it, and we get about 25% of the people have received at least one dose in the US, and 13% have received 2 doses. So we're getting there. The other analysis that this notebook does is it wants to visualize what is the status of vaccination across the country. I added this color producer depth. We've seen this in our geospatial analysis based on what is the percentage of people that have received at least one dose. If it's less than 10, the color will be red. If it's less than 20%, it will be orange. If it's less than 30, it will be light green. And if it's more than 30, it will be dark green. We'll create a new volume map, center it somewhere in the center of US. You can change the zoom start as well. We'll create a new cluster, which basically means that if you're zoomed out, the nearby markers will be aggregated. And then we'll iterate over this joint data set, one row at a time, the row ID as well as the content. I will make sure that the latitude and longitude is defined as well as the state.
George?
Yep.
There where you're defining the tiles for the folium map. Is it actually supposed to be positron? Is that cart2? What does that tiles keyword do there? I'm confused. In the folio map above. Oh, you were in the right cell. Yeah. You see where it says, yeah.
Oh, I see.
Cart2.
I think that's the layout of the map.
Okay.
Yeah. So you can do like black and white. You can do like elevation. You can do street. Similar to when you go to Google Maps and you have different options for map. I think that's the background of the map.
Okay, I'll look it up. It was just an interesting keyword there.
Oh, yeah. Yeah, look it up. Look how many other options are there, and you'll see there's different ones. Cool. So we have a location, which is the latitude and longitude of the capital city of the state. As tooltip, I want to add the state name, as well as the percentage of people who received at least one dose, rounded at 2 decimal points. I added this pop-up just to see it as well. So when you click on it, the pop-up is displayed. This features, I think we're in the latest version of Folium, show and sticky. Show means that it will show by default on the map, and sticky means if you click somewhere else, the pop-up will stay unless you explicitly close it. And then for color or icon, I used Folium icon, and the color again is given by this method here based on the percent vaccinated. So it's a dynamic color. We add this to our cluster and we display the map. Let me zoom out a little bit. So you get to see, so this is a cluster. As you can see, states that are nearby or the markers are nearby are grouped together. So Alaska is 31% of the people that have received at least one dose, Hawaii 27. And let's zoom in a little bit more. Minnesota 27, Arizona 25. Let's go a little bit on the east. Maine, Michigan, Wisconsin. Let's go a little bit to our area. PA, Delaware, Maryland, DC, Virginia. So we have to find the capital state, the capital city of each state. That's why that's where the latitude longitude is. West Virginia, Atlanta is a little bit low, 19%. You see, most of them are between 20 and 30%. You can see in the south, Mississippi, Louisiana, Austin, Oklahoma. New Mexico is doing great, more than 30%. Arizona, 25%. So look on the West Coast, Nevada, California, 26, Oregon, 24, Idaho, and Utah. So most of the states are in that 20-30% range, as you can see. This notebook, that was one simple visualization. This notebook has some other suggestions what we can try. One of them is, can you create maybe different maps, like a chloropeth, for example? I can show us an example here we did previously. Another one is, can we maybe, if you want to work with more data sources and look at different fields, CDC has their own data tracker as well as this new website or news website. Let me show you that choropleth just to get a reminder for us how it looks like from the previous notebook. This was on an earthquake notebook that we did in the past, where we analyzed data by region. So this was in Japan, by prefecture. So we'll have an idea of what is the population density. Cool. I like for us to explore the different data sets that are world in data, specifically the vaccines one. One of them is the success stories that they share every now and then. So they have some overview and timeline. This is I think this is for Germany in terms of new cases per day. Yep. I'll zoom in more. And how many of them are, out of all the tests they do on a 7-day average, how many turn out positive? And you see, this is for Germany specifically. It's about less than 10%. You can also look at this on the map or as a table. You can also look at the sources. I like these visualizations they have. They have this cool contact tracing map here or visualization. They have different patients, patient 1, 2, 3, and 4, and they're trying to encode how are these patients interacting with each other, and maybe somebody's a household, and what you can gain out of tracing basically the path of one patient to the other. That was interesting. I hadn't seen that before. Some other visualizations that I found interesting. Let me zoom out a little bit. This one was by calendar week for 2020. So if you remember, in March or in the beginning of 2020, that's when the virus started. And in the summer, there were not a lot of cases, but then after summer, the cases increased again. So you can see that in this distribution over time. And then the y-axis is by age group. So you see a cluster here in this young age group, and another one here in the older one.
The variation with age is interesting there, how that changes over time. Like, it looks like there's a really dark splotch in the 90 plus up there.
Mm-hmm.
But then over the summer, I presume, of 20, it looks like it was more the younger demographic.
Yeah, that's a good observation. And then after summer as well, towards the end of 2020, like November, December.
This isn't really showing the peak in the summer. I guess it just wasn't as much of a peak as in the beginning and in the winter.
This is Germany, yeah. Maybe
Oh,
not.
that's Germany, right? Okay.
Yeah. Then we switch gears to vaccines doses administered. So at least one dose. And you can see as of March 6th, US is ahead in a good thing, which is how many doses have been administered. Then China, the United Kingdom, and so forth. I like this visualization because I think it's an interactive one. You can track it from December 13. And let's see where the situation was completely different. China had already administered 1.5 million vaccines. And then
Is there one like detail about the Chinese vaccine? Is a coworker of mine was telling me that the effectiveness rate was like around 50%. So, I mean, a lot of people there are getting vaccinated, but
Mhm.
and I guess I wonder how that impacts the virus and like the spread of it.
Yeah, it's a good point. But I find interesting looking at how many vaccines were administered over time. So you see around January, US starts, gearing up, and then China follows. Other countries are following as well. And then this is where we are towards the end of March.
You should see it proportional to the size of the population.
Exactly, yeah. Well, the other thing we can do is we can remove these large countries for now. United States and China. And let's look at it from the beginning.
India.
So United Kingdom and Israel take over, and then United Kingdom, Israel, India, and India takes over again. Good. Oh, sorry. That was interesting. Well, let's remove India as well, and maybe Israel. Okay, Brazil. Hold on. Oh, there it is. Okay, United Kingdom. Maybe I need to remove United Kingdom as well as an outlier. But you can see it's very easy to add and remove countries here. Cool. Let's do another one. All right, Canada, Germany, United Arab Emirates, Germany, Brazil, Turkey. All right. That was interesting visualization for me. It tells you the journey of vaccinations over time. So was there anything else here? No, that was the main visualization that I found interesting. Yep, that's the same one here. CDC has their own map for how many total doses administered, how many is that per population per 100K, something that you were asking before. And then, let's see, you can click on the map. So for example, if you do VA, I think we'll break it down even more by county probably. Yep, so total doses, at least one and fully vaccinated. And then at least one per 100K, that's 26,000, so 26%. And fully vaccinated, 14%, 12%, 9%. Let's do fully vaccinated. So the darker the color, the more people are fully vaccinated. That's the legend here. So that's what, 20%, 13%, 11%, 7%. And NBC News as well has this nice visualization. This is per capita. So you get a full number as well as the percentage of the population, 14%, 14%, 13%, 20%, Alaska, 20%. And I think this is cumulative, yeah. So we are doing about 2 million vaccinations per day, yeah, 2.5. This is one chart that we want to see going up. Awesome. Let's go back to this Our World in Data. I find this website very interesting. They have a lot of research done as well. Curious what you think, and is something useful that you can use as well in your own analysis. So they have data sets on carbon, greenhouse, poverty, obviously COVID-19, poverty, plant-based diet, deforestation.
So I've seen a lot of these plots used in news reports and such, the visualizations, but do they provide access to the data sets, the raw data?
Mm-hmm. Yeah. So their GitHub, let's go to their GitHub. I think they have a very good system in place of maintaining it. So this is their COVID-19 data. Our complete COVID-19 data set is a collection of the COVID-19 data maintained by Our World in Data. It's updated daily and includes data on confirmed cases and so forth. They have other data sets as well. Let's go to their main repo. Let's see, maybe here. Okay. A nice README would be preferable. Electricity, literacy, agricultural support, air pollution, air travel. Okay, we're still in A. Let me see if there's a README somewhere instead of us looking at the names. Not really. I'm surprised.
Are they just providing links to where one would get these data sets from the actual sources? Those seem to be coming from lots of different places.
Yeah, let's see. Maybe this is a particular one. Well, 3 years ago. These probably are older. Maybe you should filter for one that's recently updated. 16 months, 3 years. Yesterday. What is this? Oh, it's COVID. 3 years. 7 months. 4 months. How about this one? Okay, then they mention a paper here, but not the actual source, maybe, or maybe this is a paper source. I don't know if I'm looking at the right place. Maybe their website will be more useful. Looks like it's articles, so they have things on demographic, health, food, agriculture, energy, technology, and so forth. Okay. That's what I wanted to share with us, friends. Let me zoom out a little bit. This was one analysis. And, just getting us familiar with vaccinations in the US as well as around the world. So I'll stop sharing my screen here and open it up for discussion. Okay, I'll actually stop the recording here for YouTube so we can have an unrecorded discussion as well, if that's what you want. If you're joining us from YouTube, we'll see you next week.